Okay, here we are back again. All right. So you've done a few exercises now on that sheet. What I want you to do is have a look at this board. And I want you to copy down these 3 exercises, please, and do them. They're very important for us to have a chat about, okay? So can you please work this out? So looking at this, we're looking at an altitude of 50,000 feet, so 1.524 by 10 to the 4 meters. That's 15,240 meters. We're looking, so we want that at that altitude. The average temperature at that altitude is minus 69 degrees C. Don't forget you need to change that into Kelvin. We know that it's minus 69 degrees C because we have instruments that measure that at that height. For instance, high altitude balloons. Okay, we're going to keep constant our volume at 1 litre. Okay, so we're going to maintain a constant volume. Obviously, if we just let it happen by itself, as we go up, as there's less and less gas, that there will be the volume will change. But we want to keep a constant volume. Okay, so we're saying for 1 litre at that, we want to find out how many moles of gas would be in this 1 litre at this height. So if we were to take a sample, for instance, of the atmosphere at that height, at 50,000 feet or 15,240 meters, we want to know how many moles would we expect to have in that 1 litre. And then, remember, the number of particles, the number of molecules and atoms combined, 6.02 by 10 to the 23 for each mole. So work out the number of moles and then work out the number of particles that there would be. Remember, 6.02 by 10 to the 23 for each mole. So can you please work out that? Then we're going to have a look and see what's that like compared to sea level. So at sea level, let's have a look at what we would get. What are the number of moles we're going to get in 1 litre? I think we already know that. However, I just want you to make a note of that. So the average temperature is 20 degrees. If the average temperature is 20 degrees, a constant volume, again, we're going to maintain 1 litre. The pressure is, we're going to maintain the pressure at the surface is 101.3 kilopascals. That's already, we measured that already. And the number of moles, I want you to work out the number of moles and also the number of particles. Okay, now remember the pressure up here, I don't remember if I spoke to you about it, but that's also measured to be 3.527 kilopascals. Okay, so there's quite a big difference between, that's obviously only 3%, nearly 4% of that. Okay, so you can see that that is quite a big range in pressure. And then if we look across here, so this is your third example. If you look across here for your third example, the air temperature is going to be minus 120 degrees C. Don't forget to convert it. The constant volume, we're going to maintain that constant volume. Okay, and this time we're going to have in our 1 mole. So we're going to maintain 1 mole of the gas. So we're going to sample 1 mole of the gas. We want to know what would be the pressure at this, if we sample 1 mole of the gas, 1 litre at this temperature, what will be the pressure? Okay? And don't forget again, PV equals nRT, and in this case here, R is equal to 8.31. Okay, all right, so can you, now just having a look at this graphic over here so you can see that that'll be the Earth, and we are looking at this height, for instance, So this is example 1 is 50,000 feet, or 1.524 by 10 to the 4 meters, and then we've got also sea level, which will be 0 meters. Okay, so that'll be 0 meters. So I want you to have a look at these 3 problems, write them down, and then answer these questions. Okay, and I'm particularly interested to know the number of moles and the number of particles here, the number of moles and the number of particles down here. Okay, so can you please do that? You've got about 20 minutes. I think that's more than enough time. Okay.
几号是 number？ 什么2？2就是那个东西8.31。对的。8.31乘204，哪来的负69
Kelvin, okay?
how do you work out the number of particles?
1 mole, and you've got the number of moles?
Yeah.
So 1 mole is 6.02 by 10 to the 23. Right.
So just
multiply it, just times it. So how many is the moles? How many did you get?
0.002.
0.002.
不好意思。对呀。徐凯，你这脑子有……为什么我不该说脏话的？
脑子有问题啊？我脑子有问题，我把我说你这答案，马上我脑子有问题。你两件合在一起。
那个是多少来着？
然后10个23次方吗？应该是那个连他的热3个月，是吧？
说的很好，徐凯，你小心点。
Have you got a number?
I'm doing it now. 哎呦，老师，我就等于我的 number 是吧？乘。这首歌也是日文啊。
What's your number? Did you work it out?
It is 1.204 times 10 to the power of 21.
That's right. That's good.
哪来的0.03？
我操，记错了，我操。1.695，操，1.695.4。
Okay, what about this one over here?
我想吧。
1.02啊，是吧？
说什么？
是0.02。
对的。老师帮我把
答案多少？
老师把问题给挡住了，我看不见了。
不好意思。
是的。哦。
那宽阔的背景。叫什么呀？
有点好听。哎呀。
So you know for the electricity circuit thing, like why are there like resistance in copper?
Copper?
Yeah.
It's a very special metal.
Like is it like the best for electricity, like conducting or something?
Copper is an extremely good conductor. Okay? And it's so good you can actually magnetize it. So.
But it still have resistance in it.
Every metal has resistance, but copper has less than most of them. Okay, so this is the ability of the electrons to travel through the copper. So, okay, so copper has a remarkable ability for the electrons to go. So remember, the electricity is really the transfer of electrons. Okay, all right. So copper has the ability to do that extremely well. Of course, you know what the big thing is. We're trying to find a material called a superconductor. This is a superconductor. So that's many times better than copper. So there's very, very little resistance. And that's what this is the holy grail of it, because that will, if we could do a superconductor and transfer power that way, that would be very, very efficient, wouldn't it? There'd be very little power loss. No worries. Okay, what did you get for this one?
0.042 moles.
Okay.
我都去看时候也是我看到了，怎么办呢？
自己做。
And how many particles?
我会自己做。对，我给你直接就套上了，就是你应该反抗嘛。
2.5284 times 10 to the power of 22. 2.5284 times 10 to the power of 22.
Okay. So what does that tell you about the number of particles at sea level and the number of particles over here at 15,000 meters? What can you conclude from that? Hey? Okay, so at sea level is much more particles at sea level than there are at 50,000 feet or 15,000 meters. So, and this is consistent with the gradient that we know about. So from sea level, it gets less and less and less and less. So for homework, I want you to work on this particular one over here. Okay. So that might be a bit of investigation to have a look at 100 kilometers. So 100 kilometers above the Earth. So you work out the temperature is measured at 120 degrees C at 100 kilometers. Again, we'll maintain a constant volume, and this time we'll maintain a constant number of moles. Okay, 1 mole, and we'll see what the pressure is. Okay, now you can do some research yourself and see how that compares with what's actually measured, and perhaps you can swap these around and have a look and see if you can match this and see how many particles are there in this given volume. Okay, so we've put over here 6.02 by 10 to the 23 particles in this particular volume, obviously, because we've put 1 mole. Okay, so we want to see what the pressure difference will be. Okay, so now the other thing I want you to do is I want you to be able to plot a graph for every 1,000 meters. Okay, I want you to plot a graph for every 1,000 meters, the number of moles. So I've given you the example of 50,000 feet or 15,000 meters. So you've got 15,000 meters and you've got sea level. So we've got 2 points right there, but 2 points are not enough for us to be able to make any kind of decision about the relationship. So we're expecting a linear relationship, obviously, but I want you to actually have a look at it by actually doing the graph yourself, and then you can see how this relationship behaves and see, does it match what does the equation match what we find in reality. Okay, that's the important thing. Okay, so I want you to, so this is your homework. Okay, so I want you to finish this, and then I want you to do one, I would think 1,000, do the calculation for every 1,000 meters, like this, or maybe even 5,000 meters if you want. Okay, I'll let you go with 5,000 meters. So you've got 5,000, 10,000, 15,000 meters, which we've done, 20,000 meters, 25,000 meters, 30,000 meters, 40 up to 100,000 meters. Okay, so I want you to draw the graph. Do you understand what I'm asking of you? Okay, so that you draw the graph so that we can see what is the relationship. So how many moles are we going to get? How many moles are we going to get for each level of height that we get up? Okay, how many moles will we get? And you can actually also work out how many particles. Okay, obviously the graph will be the same for both of them, but we can have a look and see what this relationship looks like, and does the reality match this formula? See if it's true. See, maybe there's an anomaly that appears because of the height of it. Maybe there's something that's we don't know about. Maybe there's some other factor that breaks this down. You work that out. Let's have a look at what you get. Okay? So I'm really looking forward to you doing those graphs. Please use good graph paper so that you can be accurate. Otherwise, you can plug those numbers into an Excel spreadsheet and let Microsoft do that for you. happy. I'm okay with that too. Okay, so hands up if you know how to use how you do these in Excel. Yes, excellent. Well done. So I'm counting on you to do this in Excel. Okay.
Okay.
All right, because you're going to give us the most accurate one and certainly the prettiest one. Okay. Okay, I'm really looking forward to it, and that'll be an interesting exercise for you. Okay. All right. Okay, I think you'll find there's very, very, very little particles will be up here. Okay? And that represents the gradient of gas above the Earth, between the sea and 100 kilometers, which is pretty much the beginning, the extent of the atmosphere that we call the major atmosphere, and beyond that is outer space. Okay, so it's, we would be orbiting somewhere above 100 kilometers in order to avoid the Earth's atmosphere altogether. Okay? I want you to give me the numbers and give me that graph. Okay? All right, thank you. See you next lecture.
后多旁边配的。